Hello and good evening. I am Nitesh Pranam from LabVIEW and Multisim. Today onwards, we will learn about the LabVIEW signal processing toolkits and will try to uh, explore each and every functions from LabVIEW signal processing toolkits. So for that, let's start today's session. Our first lecture is sine waveform generation. So open your LabVIEW and come into the block diagram. Right click in the block diagram. I will explain each and everything about this sine waveform, and definitely you will able to understand each and every concept, and you can utilize this sine waveform later as per your requirement and as per your project or for your application. So come here. So when you will right click on the block diagram, you will get the signal processing toolkit. In this signal processing toolkit, you will get the waveform generation, waveform conditioning, waveform measurement, signal generation, signal operation, windowing, filter, spectral analysis, transformations, point to point by point. So now come inside the waveform generation, take a sine waveform. When you will take a sine waveform, so your sine waveform will look, sine waveform function will look like this. Sine waveform dot vi function will look like this. So first, so then right click and open the label. Now you can see it is okay. The label is open. When you will press Ctrl H, so context help will open. Then move your cursor over the sine waveform, and you will get a small information about the sine waveform. If you want to go details, so you can click here. Now in the top section you can see it is offset, then reset signal, frequency, amplitude, phase, sampling info, signal out and error. Now here I am going to work on this offset. So for that, right click. When you will touch, so your when you will touch the proper node, so you will get that information on the context help. Now you can see the context help is blinking. That means I had targeted the right place. Offset. Right click on the offset and create control. So it is offset. After that, right click, create a frequency. Right click, create amplitude. Let's manage first all these things. Take a frequency, a replace, open, knob. Now you can see the frequency is visible properly. Amplitude, take amplitude, right click, replace, knob. Now you can see here the amplitudes, you can see the properly. Right click, come here, replace. You can say this tank. It's offset. Now increase the size if you want, so you can increase the length also. Now after that, right click here and come into the waveform graph and place here. Now increase the size of the waveform graph and rearrange like this. Come into the block diagram, select all and press Ctrl U. Right click in the block diagram, take a structure, come into the structure, take a while loop and place here. We know very well the execution speed of while loop is very high, and also we know to activate our while loop we need to create a control. Means we need to satisfy the condition, and the condition will satisfied by the stop button. So when you will create a control, so you will get a stop button. You can place here, and if you want, so you can increase the stop button for the beautification only. Now right click here and make a connection like this. As I mentioned, the speed of while loop is very high, so using this timing, using this wait function, we can reduce the speed of execution speed of our while loop. Right click here, come into timing, come into the wait function, take the wait function, open the label, right click, create constant and keep the 20 millisecond delay. Now one more thing is rest now. Right click here, come into the visible item, label is open already. So when you will right click on the waveform graph, the shortcut menu will open. In this shortcut menu, here the Y scale option is available. Inside the Y scale option, you will get here auto scale Y. So I am going to uncheck it. Please uncheck. After that, run the program. Now you can see here, it's sine waveform, properly sine waveform. You can see the amplitude is 1, frequency is 10 and offset is 0. I am going to reduce the frequency if you want, so we can increase the amplitude. If you want, so you can increase the amplitude like this. If you want, so you can increase the frequency like this. We can reduce the amplitude also. Now, using the offset, we can change the offset above signal. Here I am going to change the offset value -10. In this way, you can change the offset value on the minus intensity, on the minus intensity direction or the plus amplitude direction. Okay. Now, because here I am using the while loop, so I will not press this abort button. I will press the stop button. I will press the stop button. Right? Now, this one beautiful concept is here, that is sampling info. Right click into the sampling info, come here and create a control. When you will open the sampling info, you will get the sampling info like this. Here the sampling rate is, now you can see here, just a second, give me a, okay, I'm not able to touch, okay, it's fair enough. Now, you can see here the sampling info is 1 kilo, means 1000, and number of sample is also 1000. Here I am going to reduce the number of sample only 100 and try to run the program. Now you can see here, my frequency is 10. My frequency is 10. Still I am getting only one signal because my number of sample is 100. There are 100 signals who are creating this sine waveform. There is a 100 signal, okay, who are creating this, making this sine waveform. Here I am going to change something. Now you can see here, if I will reduce the frequency 10, so how I will get a signal? Now there is only 10 sample who try to design this sine wave form. Let's increase the number of signal 100. Now you will get a proper sine wave form. Why? Because my sampling rate is near about 10 times in 100, in 1000. We will get a proper 10 signal, 10 sine wave. Here 10 sine wave because the frequency is 1. What will happen if I will reduce the sampling rate? Because the 100 is my sampling rate. Now here I am going to change the, okay. Now here I am going to stop my program and here I am going to change it to 1000 and 1000 sample and sampling rate is 1000. Now Here I am going to use one error cluster. So for that you can come here and you can take the error constant, you can place here, and you can take inside the error constant. After that you can come to the boolean, take OR button and make a connection like this. If any error will occur, if any kind of error will occur during the programming, so your program will stop your execution at the same time. So thank you for watching this video. On the next video we'll try to add a Gaussian noise with the sine waveform. So thank you.